All right, hello everyone. Welcome to another Suave stream, and thanks for hopping on and joining. Um, we're basically working on two different projects right now. We have our Warzone voice controller, which we're going to get back to doing a little bit of today, and we also have the Find My Rep chatbot and voice app and all that built on Voicify. So just like we always have been doing, I figured starting with sort of a project and status update makes sense between the two, and then we'll dig in actually writing some code and touching some new stuff, and hopefully everything works out in our favor today, and all our builds work, and everything's good to go. So first, let's talk about Find My Rep. So for those who weren't part of the first couple streams or didn't catch up in the VODs on YouTube or on Twitch, where we built the thing out, basically Find My Rep is an app where you can get information about your elected officials for your region. So those include from your senators in the U.S. all the way down to like your local city officials, whatever is available to that region that you're asking within from the Google Civic Information API. So we did an integration between that and Voicify, tying it together so you could provide like your zip code and get a list of all of the representatives you wanted within that region that were available, and then also ask for like specific ones. Then we sort of had like a nice conversation flow going there, where if you asked for your senator from a zip code, you would then be asked if you wanted to learn about your governor, and if you just had to say like yes or no, and then it would go down to your mayor as well. So sort of stepping down in some basic conversational setup. We also have that deployed in a bunch of places, so it's accessible to a lot of folks now. The first thing is it's on Alexa in production, so if you enable the Find My Rep skill on Alexa, then you can go and ask it for information. It's also available on Google Assistant as a Google action. I did get a rejection from the Google Action update that we had, so I resubmitted this morning and it's back to under review. The reason we got rejected was because in our help message that we had set up in Voicify, we referred to it as the Find My Rep skill because that's what we had copied from our responses before. So that had actually been there the whole time. Even in these previous releases that were in production down here, in the one that's currently out there, if you said help, you get the response back saying it's a skill, which Google obviously doesn't want. They want to separate the vocabulary, and they want you to think of it as a conversational action, not a skill. So I went into Voicify, just changed that, resubmitted. We didn't have to touch any code, anything like that to get the update done. So currently on Google, you can only ask by zip code. You can't sort of do that flow of like yes and no and follow all the way through. We also built it into a number of different chatbots. So it's available on Dialogflow as a chatbot. There's it's available on Azure Bot Service as a web-based chatbot, and we built it into Slack. So we can go take a look at our Slack app status. So in the Slack apps, which is at api.slack.com/apps, that's where you can view the ones that you've managed. We have the Find My Rep Slack app. I updated some stuff here since our last one, our last sort of collaboration on it, and including like just basic descriptions and all that. So now it can be distributed. So if we go to like this distribute app section, you'll notice it says share this app with any workspace. So what we can do is copy this URL, and I'm going to throw this in chat. Now all you have to do is follow that link, and it looks like it just broke the URL chain. You need to grab that whole thing. And when you do that, it's going to prompt you to add the app to any of your Slack workspaces you have permissions for. And then I'll also end up adding this add to Slack. Now before we get it in the actual directory, you'll see that there's this sort of progress bar here. We're basically like 2/3, 3/4 of the way through. There's some other required things that we need to add here, such as adding detailed reasons for why we need each scope. We need to have like a landing page for it to be sent to, and a longer description that I just haven't filled out yet. The landing page means we do actually have to host a website for it, and I think I'll just end up making a blog post for it on my blog over at swapepirate.com or alexdunn.org. And then we have to like set up like all this domain ownership stuff and add the Slack button and on that page and stuff like that, and that's all fine. And then we just need to actually submit it. So I figured it doesn't really make sense to do that on this stream just because it's kind of a lot of busy work, and I basically just need to go into my WordPress, which is my CMS I use for my blog and just like make a page for it and then fill out the descriptions. But even before we do that, it doesn't have to be in the official Slack app directory. You can still use the link in chat and follow through with it. And if you're watching this later on YouTube, this will be down in the description where you can go and grab it. So add it to your Slack environment and let your coworkers and employees also learn about their elected officials and how to actually do all this stuff and contact them and make a difference. So that's where we're at with Find My Rep. I do want to do some more work to finish the Teams bot as well. I made a little bit of progress there, but like I said, I don't have like a public-facing Teams thing that I can really use there. I'm gonna see if I can eventually, but I'd like to have both a Slack bot and a Teams bot and an Alexa skill and a Google Action. And then lastly, the Bixby capsule that we started originally has been submitted as well. That just takes a while to get feedback, so I'll keep you up to date on Twitter. If you don't follow me on Twitter already, do that. I'll keep you updated with all of these deployments as they go out. So that's where we're at with Find My Rep. I'm also going to be doing a little bit of kind of some press around it. I told my team at Voicify that we did this together, and we all put in some work and we built this thing out. So I'm going to be having a blog post put together for that. And then I'll also be joining a few different podcasts to talk about the use case, why we did it, how we did it, and all that good stuff too. So keep an eye out for that. And if you have any other ideas for what you'd like to see in that Find My Rep experience to make it better, make it more impactful, and help make a bigger difference, let me know. Either throw it in chat, throw it to me on Twitter, or eventually we'll have like a Discord and Slack channel set up for this as well where we can talk through some of that stuff. But that's it for Find My Rep. Let's talk about Warzone controller. So we haven't touched the Warzone voice controller in a couple weeks because we were focused on Find My Rep and helping make sure we got it out there in time for people to actually use it and make a difference and contact their government and all that, while sort of riding the wave of motivation and growth and stuff from Black Lives Matter movement and everything else going on right now to make sure that people were becoming even more aware of what they could do. So we took a few weeks off. I do want to get back to this now because I have bigger plans for this app, for the Warzone voice controller, where eventually we'll end up making not just a controller for doing things in Warzone, but for enabling people to use their virtual assistants or chatbots in a remote source or wherever, really, to actually use like a keyboard and mouse and interact with their PC just by running some software and talking to it. That's the long-term goal, and this is really sort of the proof of concept for it that's a little more fun. That way we can all sort of work on it together. So progress on this, basically, what we have is an Alexa skill and Google Action, all sort of custom built and all in .NET. It exists as just one ASP.NET Core API project on Azure, and then we have a UWP app that basically acts as the local client on the machine that you're playing the game on. And essentially what we're doing is when we get a request from any of the virtual assistants or chatbot platforms we end up deploying to, we take that and then send over a WebSocket connection down to our UWP app, and we also have a WinForms example in here too when we were testing some stuff. We send it down to the Windows app, and then the Windows app at this point is doing key injection. So I have the code up here, and if we go and look at our main page XAML for our UWP client app, you basically see here, and we basically need to like fix some of this stuff up because it's all busted from the last day we left it in. For each event that we get, like for each intent that we pass along, we're using this hit key method, and right now this hit key method is using input injector to try to inject what our key should be that we want to press, and that works super well, and the whole flow was set up. We did that all in like originally like an hour or something like that in our first stream. But basically, we just found out that most games running on the desktop just don't care about this. They don't care about your input injector. It's all ignored. Everything has to actually go over a USB device, which brings us up to speed here. And what we have now is a plan to build a USB keyboard that our UWP app can talk to, and then the keyboard can talk back to the machine. And the way we're doing that is with this this brand new Arduino Leonardo board that can act as a USB keyboard. Now, I haven't done Arduino work in a long time. And it's probably what we're going to be spending most of our time today on. But there's some interesting lessons to sort of pull out of this. I'm going to be learning some more stuff about Arduino and communicating between UWP apps and the boards, which has uses way beyond what we're doing right now. But we also can basically take those core concepts and expand them into other use cases. So in the end, the goal is Alexa talks to our API. Our API sends requests over WebSockets via SignalR to our UWP app. Our UWP app sends commands to the Arduino board, and then the Arduino board sends keyboard inputs back. Now, we had the whole time in Arduino Uno. This one is by Sunfounder, and basically we couldn't use this board because it doesn't actually have the capability of acting like a USB device. Hold on, let me just switch to my camera only. first things first, I don't think I have Arduino IDE installed because, again, I haven't done this in years, and I never really did anything complicated. So let's go download Arduino's IDE. All right. You can code online? What? I did not know that. All right, we're going to download the Windows app. For now, we'll just download, but we will probably donate to the Arduino project later. Okay, so this is actually in the Microsoft Store, which is interesting. And I don't think it's a UWP app, which is, I've never deployed anything that's not a UWP app, but we'll open it up in the Microsoft Store here and get it installed. Now, I have pretty good internet, so this should download pretty fast. There we go. These are the numbers I like to see. Alright, cool. Already downloaded and installed. So let's run it. And oh my, this is brutally small. Let me see if I can adjust my Windows settings here. So I'm going to make this monitor we're on right now a little bit bigger in terms of its resolution scaling. And now when we full screen this, okay. Does that look all right, chat? Is that visible? Oh, I guess I can zoom, make it even bigger. Okay. Let me know if you need me to zoom in more. This is like a lot of white space to take up. So the first thing I want to do is make sure that we can basically actually communicate to the device and that we weren't shipped a faulty one. So to do that, I'm going to need to plug it in, and then I want to write a program here that's going to basically send commands to flash the onboard LED. So every Arduino, I think this one comes with one too, have a few different, or at least one onboard LED lights that you can use to flash. They can be used for status indicators and all that good stuff. So I need to plug this in, and I've got some micro USB here. Last time on stream we tried to plug anything into this USB, we B-sodded my desktop, so hopefully that won't happen. I'm going to be very delicate here plugging that in, and plug this in up here. Actually, I'm going to plug it in. I've got a hub down here as well. It's a little easier to reach, so we're going to try plugging it in there and hopefully not unplug everything else that is dependent on. Okay, my mic seems to still be working. My camera is still working. This is good progress. All right. So first things first, we got the on light on. Let me switch back to camera here. Get the onboard LED to flash, and also try to not get it crossed up with my mouse here. Okay. So we're going to say Arduino blink onboard LED. Blinks the onboard LED. That's what I want. Oh, I don't need to do that. I just want the regular one. I've definitely done this before. I am sure there's a tutorial for it. Arduino blinks the onboard LED. Internal LED blink. Okay. So to break down the sort of code here, there's two methods or functions, whatever you want to call them, that you get. And Arduino is written in basically C. So we're working with the sort of core level C functionality. We import header libraries and reference them with zip if we're going to need an external library, which we might. We'll see as we get a little further along. But there's two methods here to worry about. We've got setup and loop. Now, essentially, the way it works is setup is called once when the code is first executed. So when you first deploy it and you start running that code, whatever you put in here is going to start. Loop, just like the name says, is going to iterate over and over again. So this is where you can put things to say like, if we got an input on this loop, right, we're running over and over and over again. It's just kind of sitting on this. If we have some sort of event happen, like in our case, we're going to try to send a serial command down, then we can do something with that code, halt the loop, and then when it's done, it'll go back to looping. And so basically we need to have these events registered of like, hey, this current thing has happened in this loop. Let's stop. Let's do some code. And ideally what we're going to basically do here is in the long run, like, get serial input, take serial input as string value, send keyboard command of string value. And that's all we really need to do. That's like the most simple business logic. Now, I haven't done this before ever because I've never used the Leonardo. And I think also, by the way, the micros also support this. They're both around like 15 to 20 bucks depending on where you're looking. I've done serial before, but not in a while. So some of this stuff will be brand new, never touched before. Some of this will be relatively new. So in this case, with trying to get the LED to blink, we basically do some setup to set the pin mode for the LED that's built in. This is a constant value that already exists, and we set it to output. I like how they actually have these comments here. So I'm going to copy this, and we're going to create a new sketch. And we can paste this. Now we can just basically verify it, which is like building. I'm going to go ahead and put all this stuff in my project file. So this will all be in the same repository too. I'm not able to find my stuff. Users, me, projects, and Warzone voice controller, source. Okay, and we're going to have a new folder here called Arduino. And we'll call this basically hello world blink onboard LED. All right, it's verified. It has, or it is. Now it's done compiling. Down here we get our status and our output and everything else. So now let's upload it, which is the same as actually, it sends it to the device to actually run. So we got to choose which port, and luckily it tells us which one it is. This is going to be very important for us to know what port it's running under when we get to running it from our UWP app. So we know this is the Leonardo COM4. Hopefully that doesn't change later, but we can get it started here. So the code here is basically saying, like, we're going to write to the LED built in to set the power to high, right? I'll turn it on. We'll wait half a second, then we'll turn it to low, then we'll wait half a second. So essentially we're going to blink every half second. Now, let me switch back over here to camera only. Scene as well. Okay, I'm gonna unplug it. I'm gonna replug it back in, and now let's see if we can upload it. It's uploading. We got a status bar here. And like a spinner of doom going on. Also not sure why we got like two different windows here. Alright, maybe I just need to restart this. Let's restart these. How about that? I'm not gonna save that sketch. We can go over here to our source again, Arduino, and open up this Hello World blink. Try running it again. Okay, we're uploading. This is normally much faster. Like, we just did it and everything went fine, I think. Or was it stuck before? restarting it. Problem uploading to board. Okay. Let's see here. Upload. Does anyone in chat know if there's a way to view like more detailed logs of this stuff while it's uploading? It's also interesting. I don't know if you can see this down here. Let me pull it up into the middle. It actually thinks that there's an Arduino Uno over COM4, but this is a Arduino Leonardo, not an Uno. Our Uno is not plugged in. All right, well, it's great start, Arduino. Arduino hung on upload. I don't even know how to get to those logs. Let's see here. It's a serial monitor. The port is busy because it's still trying to upload. Oh, we're not a Leo. Maybe that's why it thinks it's the wrong thing. Let's try uploading now. Now we have Leonardo. Okay. Error while doing something. Port busy. That sounds right. All right, we're gonna unplug and replug it again. Now the port won't be busy. Hopefully we're still trying to upload to COM4 and that didn't change. I mean, it seems to recognize it there. Okay, let's see. Verify it again, make sure we can build. Compile, done. Uploading. There we go. Okay, we're done uploading. What an amazing concept. Now, what I want to do is I want to be able to send input to it from our UWP app. So like I said, I haven't done that before, so we're going to learn how to do that. And the way we're going to validate it before we try to just jump in and do everything and debug it, I kind of want to do it in steps, is in the loop, whenever we hit one of those serial inputs, we're going to basically do this. We're going to blink the light. So every time we say something to the app, we'll blink the light and then we'll be good to go. So let's start doing some research on that. UWP send serial info to Arduino. Look at that, I'm not the only one that's looked it up. We'll pull up some URLs here that will help. Character read and write. So there's a namespace for this that's built in. I can zoom out a little bit here. Windows devices serial communication. So basically, we need to be able to register it, that we're going to be talking to that device. I think you can do like wildcards in here too. And then you send commands to it. So I know they have a sample where they have like a whole sample where they have like dynamic LEDs they're pulling up and stuff like that. Let me find that. UWP Arduino. This is the one, serial Arduino. Okay. Shows how to use the Windows Devices Serial Communication APIs to communicate with an Arduino device. This sample allows the user to configure and communicate with an Arduino board that has a simple wired circuitry consisting of 4 LEDs and a temperature sensor. ours is going to be even simpler, where we're going to have no circuitry. Everything will just be running over one wire and one little LED. Connect and disconnect using device selection list, communicate with the Arduino board and toggle the LEDs, and get readings from the temperature sensor. Okay. Alright, so I need to either download, this is like a whole bunch of stuff, isn't it? Oh yeah, this is like a massive repository with samples of everything. That's fine. Let's clone this. So we're going to clone the GitHub repository. We want to go to projects, sure. Thank goodness for fast internet. Okay. We've got it. Let's go to projects, Windows Universal Samples, and there should be an Arduino, or Serial Arduino is the name we were just on. Look at all these samples. Serial Arduino. We want this, and we want that. Oh, why did that open Visual Studio 2017? Don't do that. Oh no. No, don't. It takes forever to load. Okay. We want it in 2019 because, you know, we're in the year 2020. So that makes sense. And we should also take a look at the sketch they have. So they have the sketch here. They also have the fitting diagram, which is really cool, but let's pull this up. File serial command needs to be inside a sketch folder named serial command. Fine. Okay. So right away they're pulling in some libraries, which we need to have. And I'm not sure if they are here by default, but we can take a look. Let's see here. Okay, so this is a different library we need to either download or reference. And we don't really need the Dallas temperature stuff or anything. So let's just take a look at what's going on here. So we begin listening to serial events, and it looks like the serial command thing allows us to basically do it more like event-driven stuff, where we're saying like, hey, if we get this command, go fire this method or this function. Then we have the unrecognized command one. And then we're setting different pin modes here, because again, they're going to be doing stuff in their example where it's powering LEDs and temperature sensors and stuff. So like, we don't need sensors begin, we don't need the pin mode stuff, and we do need the serial command listening. So on the loop, we just keep reading over serial, and then you can see we have this set LED on. So basically what we can do is we're still going to want the serial command stuff, so let's go see if we can't find this in the libraries. Include a library. I don't know if software serial is the right one. I know there's like a, yeah, okay, this is where we can search. No results. Serial command. This will install. Okay, it's installed. So let's get rid of the stuff we don't need, right? We don't need this stuff. I don't even think we need software serial. Maybe we do need it. We can keep these. I don't think we're going to need these, actually. We definitely don't need the temperature stuff. We can keep the debug message sort of function defined here. We've got serial command. We don't need one wire. We don't need Dallas temperature. We don't need device address. Debug we can set to true or false, which is nice. We'll keep all this stuff. Actually, we don't need get temperature. And we can keep the default one. We don't need pin mode, and we don't need to begin the sensor listening. So this is good. We can keep LED on, LED off. Let's get rid of this whole get temperature stuff. We'll keep set debug. And we'll leave this sort of like unknown command stuff, because that'll be super useful. But instead of doing LED off like this, what we're going to want to do is basically call this, right? So we need to set this. That's our LED off. And this is our LED on. We do also need to do that initialization. So if we go up here, we need to set the pin mode here, and we'll do that in setup as well, right alongside setting up the serial commands. Great. Save that. Let's see if we've got this open now for serial Arduino. Let's take a look at what's going on. So looking at main page XAML, we've also got two different sort of scenario 1 and 2 here. Assembly references are missing. Let's see if we can build this. Do by 86 build. 41 errors. Oh, it's got to restore NuGet packages and stuff. So restoring all the NuGet goodness down here in the bottom left, you can see. And then if we just show the XAML side, let's take a look at what's going on here. All right, so we've got a grid and a split view. So the left side pane will have a relative panel. We've got a list box, so a list of items here. And it's just got a title, and those are the two different scenarios. Got a footer panel. We've got our right side. This is the header panels and the scenario frame. All right, so we got a frame here, and I'm sure we're setting this with something else. Okay, so we got LED, temperature, and connect and disconnect. So this must be where we're going to be setting up connecting to the device. So this is probably where we're doing the serial input option reading and deciding what port to connect to. And then this looks like, yeah, so now we can actually load things. This is where we can both view the temperature and turn all the, view the temperature and turn LEDs on and off. So what we should expect if we get this to run is if I flip any of these switches on, we should turn the onboard LED on. If I switch any of them off, we'll turn it off, because we're not doing like the pin specific ones and mapping these to actual LEDs, although we certainly could. I've got all the sort of hardware over here as well, but for now we just want to show that we can take a serial command, and then we'll learn how to do that, kind of dissect what we've got going on here. So first things first, let's verify. So let's compile our output. All right, so we're missing the serial command here. Let's see if we can't find this. We might need to like actually reference a zip of it, because I don't think it was the thing that we saw there. All right, this was originally written by Stephen Cogswell, which is what our library is saying. So is this the latest then? Modify version, smaller footprint. Okay, so let's download this because we need the zip file. Download zip. And then what we can do from here is reference the library. So we go to include library, add a zip library, and we'll grab that from downloads. This is like brutal. Hold on. What did it just down? What did it call it? Arduino serial command. Where are we here? This. It's like it didn't. It's like it's not finding it. Do I need to like refresh this? This is a zip file now. Downloads. Downloads. Let's try again. Maybe it just needed to refresh. Downloads. Not. Oh, here we go. It's not in alphabetical order. Super cool. Okay. Library is added. Now let's see if we can compile. Nope. Add default handler is not recognized. Set default handler. But they probably just changed the method here. All right, can we verify now? Aha, we've compiled. Okay, let's upload it. While that's uploading, it once again thinks there's an Uno there, which there is not, so maybe we need to change that again. Can I like cancel the upload? Alright, there we go. I need to tell it that it's not an Uno. We've got our friend Leonardo here. And we are on COM4, so now let's upload again. Error occurred. Error touching, serial port, COM4, port busy. Okay, I'm gonna unplug and replug it again, since that seemed to help last time. And let's upload it. Done uploading. Okay, it's on. Our board is no longer blinking, which is good because we need to send it serial commands. So let's see if we can't run this guy. Okay, no device is currently connected. We both know that's not true. Alright, connect to device. Is it gonna let me choose from one, or? Select an Arduino device. They're not showing up here. I'm curious. I'm going to try to plug in my Uno here. I wonder if we're just going to have, I wonder if this is going to have a problem recognizing the Leonardo. So I've got the Uno over USB. I'm going to plug it in and see if it shows up in this list box. And hopefully this doesn't brick my machine again like plugging in up here did last time. You can still hear me, you can still see me, that's great. Okay, so it did recognize this one. Interesting. If we connect to this one, don't want to do that. So why is this showing up? Disconnect. Let me try plugging the other one in up here. Got some fun USB debugging going on, and not the kind I'm used to. Alright. Plugging into the same USB port we just plugged in the other one. Maybe someday if I can actually plug a thing in. Come on. There we go. Interesting. Why aren't you being found? Let's go take a look at that code then. So in the connect disconnect XAML, what is this being bound to? We've got a device list source. Just a collection view source. Where is that being grabbed from? Check the code behind here. Alright, on navigated to. Device is not connected. Oh, this is the wrong scenario, duh. We want this one. Alright. So we got a reference back to our page. We got some event handlers. List of devices. Alright, we got a new observable collection. So this is what we're going to be setting here once we get them. So when are we adding to these? Initialize device watchers. Create watcher. Let's see if we can using the code was not working. Let's see. UWP serial device information not finding Leonardo. Wondering if our permissions are weird. I want to open this with the XML editor. Yeah. Alright. So this is interesting. Why we have like a static thing here. Maybe we need something else. Alright, any device ID. Maybe that's the key. Any. Let's try running that. Now if I replug it in, nope. If I plug my other one back in, does that show up again? It does. Why? I wonder if we're sort of already running into that issue of the USB connection. Let's see if Leonardo even accepts serial. Arduino Leonardo serial. That's obvious. Alright, we still got our Leonardo open. Can we serial monitor? Board at COM4 is not available. Oh, it's probably on a different, it's gonna be on a different port now, isn't it? It's on COM7 now. I'm gonna plug it back into COM4 for old consistency's sake. Back in over here. Sorry for sort of the runaround on this while I'm just plugging things and unplugging things. Alright, now if we run it, we'll upload it again, although we shouldn't have even had to do that. Now let's monitor serial. So if we get LED on, LED on, yeah, that does work. It is sending stuff over, right? So just to sort of show you what happened there. The serial monitor is cool. You can send serial commands over it. And what just happened is I typed LED on and hit send, and our little light is on again. Now if I say LED off, which is the other command there, I'll hold this up, and then I'll hit enter here. switch back to here. Sorry about that. We know we're running on COM4, and that's where we're getting all our information from. So instead of saying this, device selector, get device selector from USB vidpid, and then we pass in the VID and PID, we just say, just get us COM4. And then we get the list of devices available. Now that over here did work. So let me try saying connect to device. Possibly opened by another app. Alright, so that probably means that we can't have this connected as well. There we go, now we're connected. So now, if I turn any of these on or off, okay, we're writing them, but I'm not seeing the light change over here. So let's go take a look at the back end side here. When we switch LED 5, we want to write an LED command, which means we're writing LED on plus the LED number, and I wonder if we're just not accepting that. Let's do this instead. I want to write just regular old LED on, oops, and that new line there. And in this scenario, I also just want to write LED off. Don't care about the number. Oops, did that same thing again. We just want to send that. Comment these. Comment these. These are the same, right? Actually, we don't even need that at all. And now we do have to rerun because we can't just actively reload that code. All right, we got our device. We are connected. If I send on, it is not doing anything. Let me disconnect. And now back in Arduino, I'm going to reopen the serial monitor and send LED off. Oh, that's just not even doing anything. Let me try re-uploading this. I wonder if it just didn't like that I was like connected from the serial monitor over here. Okay, so now it's off. I'm not going to connect from the serial monitor. I don't want to do that. Over here, I want to connect, and turning these on and off does not seem to do anything. Oh, wait, actually, yeah, it is. Oh, okay. Wait a minute. Oh, this is just telling us we have commands coming in. All right, so here's what's interesting. Let me switch to my camera again. And I'm trying to figure out why sending that same command is not actually being read. We know we're getting the commands. We know that these work because when we send them from the serial monitor, everything comes in. Where is our debug writing to? I don't even know how that works. Oh, we're serial printing, so that would be in the serial monitor. We're not really getting it. LED on. It's working, but we're not getting any output here. Alright, I'm going to close this. We'll reconnect from here. LED on. Do the thing. Alright, maybe it's just the code that we're sending is not sending the right commands. Maybe it doesn't like these new line reference things here, so I'm going to rebuild. We'll reconnect. Still nothing. Still seeing the same thing with that RX light flashing. But why? Don't need that anymore. I wonder if it just doesn't even like these. I really wish that I could just like attach a debugger. Maybe if I debug true, re-upload. Okay. Let's reconnect. Serial monitor. We can't open that up. Is it going to be written back here at all? Data writer. Let's go back to the original thing that they had. Now, I don't know if this event handler that we have in Arduino, like with this serial command, add command, I don't know if it's like, hey, if it starts with this, execute it. That might be the case. Like if we go look at, let's see, I gotta pull up the original Arduino UWP. Right, if we look at the original sketch, it's the same commands. We're getting the next serial command. I wonder if we still need these. Let's do this. Or I wonder if it's a format that it expects or something like that. But we know it works because it's working when we send it from the serial monitor. But maybe it's not exactly the same. So let's take this. We'll just do this. Rewrite these back to start. All right, we'll do it under the comment. And then instead of digital writing this, we'll digital write to the hello world one. Right, so we want that. And this one will digital write LED built in to low. Let's upload that in. Now I want to test from the serial monitor again, just to see if we can send the LED off and LED on and get that to work from here, and then we'll try again from the other one. So if I say LED on, LED not specified, at least we got the debug message that time. So arg is null, serial command dot next. What if we should set the pin mode ahead of time? We'll just do this. Get rid of these if statements. Upload this. Alright, LED on. It is on. LED off. It is off. Great. Are we not connecting over the right, like, thing? Is that... Alex new line. Alright, let's try rerunning this. Connect. Send. Still nothing. It's getting them sent over too, that's the thing. And I don't know, like I can't monitor. Is there something I'm missing here for handling the like a data reader? Temp, write async. Detach stream. There's motion at my front door. Wonder if I'm getting a package delivered. Wow. Write async. Feels redundant. This is what we're using when we're sending those commands. Why? Wish I could read what is happening. Not that one. So it clearly doesn't like the way that I'm sending these, I think. What is this class? Who are you, data writer? Let's see if there's a more basic way. Like this might just be overkill. Let's do this. UWP send string over serial to Arduino. Yeah, it's all great. It's exactly what we want. Yeah. Me too. Nothing happened. Okay, so maybe I'm just missing something. By default, serial monitor sends 2 characters on Windows 10 to the board for each input. Fortunately, this can be changed. Alright, so maybe we do need to come over here. Let me disconnect from this. carriage return. And now connect. No, that still didn't work. Sort of reading through this. Fix the example discovered by the sample and is able to connect to it. Oddly enough, at this time I was able to blink the LEDs in the UWP sample app. I disconnected my Arduino board and reconnected. I had the same experience. The board was discovered, but the example didn't work. Following can make it work. Connect it to the Windows 10 device. Open Arduino. Upload the sketch. Open serial monitor. Test the sketch. Close the serial monitor. Open, connect, blink. I mean, I feel like we've done that. You just use a different temperature sensor. Ooh, I'd much rather use that too. Display name sounds way better. Alright. This is in the connect and disconnect. The list of devices. Find device. Is he saying? Device instance ID. Oh, that's why. It's in a different class. Wait, what? Alright, that doesn't really matter. Pedantic. Alright. Let's try what this guy said he got to work, right? So, I'm going to do it without debugging. We're going to go in here. We're going to upload fresh. We're uploading. We are uploaded. I'm going to send LED on. It worked. LED off. It worked. Disconnect. Go to serial Arduino C# sample. Connect. Send. No. Let's update this to also just send that raw string instead of sending like with the state and everything. We'll just swap these. Connect. Still nothing. Disconnect. Open serial. LED on. LED on. LED on. Interesting. When I switch this to carriage return, it does not work. I was actually getting the same behavior there. So do we need the fresh new line as our indicator? Let's rerun this. Disconnect. Connect. Ah, that's working. Okay. Check this out. Progress. We learned that the stupid serial carrier makes a difference. It's on, and our LED switch is on. It's off. It's off. On, off, on, off, on, off. Wait, on, I mean, off. That's great. Okay. So, we now know how to send data over. We should now try to figure out how to send a keyboard stroke back. So let's go take a look at how we do that. So let's say we'll just keep working in this sketch, and then eventually we'll get it to work with everything. So Leonardo DiCaprio, send keyboard Keyboard.write. Okay. So we have to call keyboard begin. This is doing like a resistor thing, which we don't need. And we want a keyboard write. Can we... If we call begin on this, are we going to have a problem? Can I wrap like a keyboard begin and keyboard end? Is that allowed? Let's do this. On set LED on. We'll write to that. We'll also say keyboard begin. And I think we need to bring in keyboard. Include keyboard. So I think that's built in. But let me make sure I just did that right because I don't know what the hell I'm doing. Oh, it's just like straight up built in. We don't need to even include it. Built in to the SDK. Okay, let's see. We might have to throw this up there. I'm a little worried about kind of bricking the Arduino, but whatever. All right, we're gonna do. There's keyboard.write. So let's go over here. Under our begin, hopefully that's synchronous. Keyboard.write on. Keyboard.end. Is that the other method we've got access to there? End, yeah, okay. Begin and end. So all in the same sort of stroke here, pun very much intended. When we get it, we're going to try to get our keyboard. We're going to write on, and we'll do the same thing over here, and we'll write off. Off. Auto format. All right, let's upload this. We'll see if this works. I have no confidence. Keyboard not found. Yes. So we do need to include keyboard.h. Include keyboard.h. Verify. What? Oh. Semicolons. Compiling. We compile. Let's upload it. All right. Uploading. Taking a little while to upload. I wonder if it needs to do some special stuff for keyboard. I hear my computer putting in work over here. Oh wait, we got an issue? Oh, port busy. Are we still connected over here? Oh, we totally are. That's why. Alright, let's upload again. That's the sound I like to hear. Alright, we've uploaded. In our Windows app, we're gonna... Can't find it. Now it's done uploading. Do I need to disconnect and reconnect? Or did we already somehow brick everything? Oh, this just switched to COM 8. Damn it. Damn you rotating ports. Alright, so over here, all we need to do is in our thing here where we have COM4, change this to 8 since that's now where it lives for whatever reason. Alright, we can connect. Now, I guess I don't really know how we're gonna prove that it typed anything. let's do a different one. We can't if we have to flip the switch, we can't type anything. Okay. I know that we can do other stuff, so we can like press and then release. So if we try to do like an alt tab, I think that would be a good one. I think if we do press, then we have to do release all. Okay, so basically we want to do basically this, right? So run Windows. Over here, we want to press this. And I think that we can do Alt, and then I think there's also Tab. Let's see if we can do that, if that's valid. Tab is not in scope, right? What's the one for Tab, or how do I find out? Do they have a dictionary in here somewhere? Key characters. Let's see. Arduino key press tab. Is it like left tab? Is that what I'm missing? Oh, it's gonna be like key underscore tab, I bet. Yeah, okay, that's fine. That makes sense. Build, deploy. We're still connected over here, so we gotta disconnect first before we can deploy anything. Upload. Done uploading. So now, back over here, we can connect. Now, when we flip one of these switches, it should do an alt tab. Oh, it's we forgot to release all. No. Okay, that's fine. We're gonna unplug it. And at the end of this, we need to do. Almost messed up my machine there. Release all. We're gonna do that on both. Right? All right. We're gonna replug it in, re-upload. Hopefully, it's still not sending those. We're still on COM 8, I think. Oh, we're still connected. We gotta disconnect again. I keep forgetting. Upload. Done uploading. Connect to device. Now, if I flip a switch, it should alt tab and release them. Boom, we're gone. Switch it off, gone. Awesome. Okay. So now, this is awesome. Okay, so super easy. This is such little code. So let's recap what we got here, and then let's figure out how we can kind of connect things. And then we're gonna want to do like different serial commands for our actual stuff. So basically, we can get rid of this stuff too. We're grabbing the built-in LED. We're starting to listen for serial, or we're basically beginning our serial port listening. We're using the serial command library, which basically lets us add event handlers, which is super useful. And essentially, we're saying if we get the LED on command over serial, call this function. If we get LED off, call this, debug that. Otherwise, everything else go to unrecognized. Then in the loop, all we have to do is say, we're just listening to serial forever. Now we have our set LED on, right? So if we get LED on, this code is called, where we're telling it to turn on the LED light on our board. We have that working, and now we're saying do an alt tab. And we begin opening up the keyboard, we press something, we press, in this case, left, alt, and tab, and then we release, and then we end that transaction on the keyboard. We don't want to keep that open for too long, otherwise we're kind of screwed with trying to use the IDE. And then LED off, we turn the LED off, but then still alt tab again. And then the debugging stuff just tells us whether we can write or not. And this is our unrecognized command where we debug a bunch of stuff. So what I want to do is take this and start actually writing it in our real code here. So we're going to do a new sketch. We're going to start here. We're going to save this in our actual file here. Create a new folder. We'll call this Warzone controlled keyboard. I'll just name the sketch the same. I just want to separate it from that hello world one. All right, we save it. Now, I'm going to get rid of the stuff that we basically don't need. I don't want the debugging stuff. I don't need the unrecognized command. Actually, we can leave that. That's fine, I guess. And then basically, we're just going to want something where we grab the command that's sent in and we just like execute something different. So we're going to want a different function that we can call. We don't need this. We don't need the onboard stuff at all. So we can get rid of this pin mode. This is all fine. This is no longer owned by Microsoft. This is owned by me. Debug is fine. So let's say like we get reload, right? So we're going to want to call reload. And if we get reload, we don't need to get that. But what we do want to press is R. Or can we do, yeah, we'll do press R, and then we'll release it. We'll get rid of this for now, and we don't need this whole method. Basically, we're going to duplicate this, and we can abstract it just to pass in a character and be like, type this thing, right, and just send that command, and then we're good. But for now, let's try to get it working from connecting our Arduino to our UWP app that's listening to everything. Just get it all set up right. Then we'll listen to serial, and if we get the reload command, that's what we'll send back down. Then we want to press R, and then we'll hop into game, and we'll try with that. And if that works, and I really hope it does, because if it doesn't, I am like straight up out of ideas for this, and we're going to have to do something else, which is fine. We've got a whole backlog of cool ideas. If this works, though, then we can just go in and add the other commands for the rest of the game. And then we'll go in and drop in a game and see if we can't play yelling at my Alexa device. And then we'll also get it published on the Alexa skill store. So that way, next stream, once it's approved, you all can actually go enable the skill and yell at it from your own homes while I'm on stream. And we can like manipulate the guy I'm playing. So like all reloading, putting on armor, crouching, and all that. Maybe eventually shoot, because I think there is also the ability to do mouse components over this USB as well. That will all work, so I think that'll be really cool. But I'm going to be right back, use the restroom real quick, and grab some water, and then let's get into moving all of this stuff over, running this on ours, and then updating our UWP app to do all of the serial stuff that this messy sample does too. So be right back in like maybe a minute and a half, 2 minutes. Okay, we're back with water. I'm getting so excited. I feel like we're finally close to what we always wanted. I should be careful not to spill my water all over the little board here. Okay. So, we basically need like this whole page. Let me get this back up so we can look at it. Oh, not Arduino. Man. This. Right, like we need this stuff, this page, in our UWP app. And we basically don't need this stuff. So, this just feels so bloated. Like, I feel like there's, like, way cleaner ways to do this. Can I auto-connect if it's there, maybe? I don't know. All right, let's not get too far ahead. Let's do this. We're gonna create a new page. We're back here in our example. I'm gonna try to build. I don't know what's going on here. All right, it's just not able to find my XAML stuff, which should be cleared up after a build. And we don't need this, and we don't need this, but we'll keep that one open. All right. We are building. So we're going to switch to our client. And essentially what we need to have is a page to do the connecting to the device and a page that is basically our log where we connect to our to our API over SignalR, right? So that's what this main page is right now. What I think I'm going to do is make this a different page and basically have like a navigation page here just to do the two different things. Or I can just put it all on one page. So putting it all on one page here, I'm going to, we'll say, connect to remote controller. Let's just make this a stack panel. We don't need the row stuff. And then we're going to basically just steal everything from this view and put it in here. So, go to serial Arduino. Let's go take a look at the serial 1 disconnect XAML. So I need to take these page resources. I'm going to side by side these. Right, we need page resources here because this is what we're going to be using for binding our device list. And then we'll take this whole grid. Just take the whole thing. I don't really care about the styles here, so goodbye. It's gonna be ugly. Alright, now in our code behind, we need like all the same stuff as this. So this is basically like a whole bunch of events going on for handling when devices are ready, when they're connected, when they're disconnected, and setting state and managing state. And I personally don't really like the way this is built, where this is all just like all up in this one single page, but for now we'll just grab it all and slap it in ours, and then we can start to pull things out and figure out what we do and don't need and everything. But let's, oh my goodness, this is just massive. Okay, that's fine. We'll just, everything's fine. Ignoring the sloppy code. I'm gonna just go ahead and put this all the way down here. Tempted to put a region just to hide the garbage, and we'll say like this is all from the Windows Arduino serial example. Not my fault. Alright. We're gonna get rid of stuff that we, let me just, is this the thing? Where did this notify user come from? They got like random ass helper methods all over the place. What is this, main page? Fine. We're all notifying users. Oh man. Updates to another one? Okay, let's, yeah, forget it. Anything that is notify user, user's not getting notified of anything. We're just gonna write this the right way the first time. Give me all that stuff. We're gonna need these. These are classes we need to pull in. That doesn't feel right either. This device information class. Oh no, that is right. All right. We do want to take these though. What are these? Oh, yep, we need these, we need these. No. Sample configuration. Wait, this is like another partial for the main page? Nope. Alright, we're going to take these though. Can I copy across here? Is that allowed? Nope. Paste. Fine. You know what? We're going to just grab the raw files. Like the monsters that we are. Windows Universal Samples. Serial Arduino is the name we're looking for. And we're going to grab these three and bring them over to Warzone voice controller client. Boom. Please show up. Does this still do like the old project style? Oh, of course it does. Alright, include those. Alright, now we just need to grab these namespaces for these things. This is that. Get rid of this. No notifying the user. None of that nonsense. User's gonna have to figure it out themselves. Suspending event args. Definitely not web UI. Not doing anything like that. Int and method group. That's an int. List of devices. Oh, we don't have that yet. We need to pull in the namespace for observable collection. Hopefully we're still on COM8. We'll find out. We could always change that to make that like a configurable string too, and not have to like do the other nonsense. We're close. I don't even want root page. And this is in our constructor, so we can just, I think we already have some stuff going on in our constructor, right? We do. Close to building. What else are we doing with root page? Root page is us. Only one little error left. No issues found. Can we build? No. More things. Oh man. Alright, our main page needs a current that's set to itself in the constructor. Like freaking monsters that don't know how to do context. Static, main page, current, and current is this. There, I hope you're happy. Oh wait, we don't want to notify users anyway. Yeah, screw it. I was gonna say we shouldn't need a reference to our page from something like this. Notify type. Man, you don't even exist. Be gone. Nope. Nope. No notifying users. Oh, I didn't make it public. Still don't think we actually need this, but whatever. We'll assign it anyway. SDK template. Yikes. Alright, we probably need to check these other ones that we just haphazardly dragged in here too. Alright, now can we build? So the plan is to get this to work with one example, set up the other examples, and then we can clean this up. But for now, to be honest, I just don't care. And hopefully everything just works. All right. We need to upload this. have our sample. Cool. We can connect, maybe. Did it connect? Maybe because I can't tell because I'm not doing the notify user thing. Connect to a remote controller. If I just go here, let's see. Alexa, open Warzone controller.
Welcome to the Warzone controller. Issue a command like jump or cut shoot.
Reload.
You are reloading.
Oh, okay. Oh, we're not sending anything back right now. Duh. Okay, all that's fine. And we did type it because we're still doing the virtual injection, which is hilarious. Okay, so what we want to do now is instead of using the key injector on this hit key, right, we'll leave it here because I think it'll be educational for people to have anyway. So like, note this doesn't work with video games. Needs to be USB. So now we send serial commands. So let's go look at our LED section, right, our other page here for how we actually send the commands. So basically we get this write command, and I want to just take this. Let's see what we can do here. Right, so hit key. We can still do that. Again, we're not notifying users. And what we want is this. Oh, whoops, data writer object. We're gonna throw a debugger dot break in here just in case. Oops, not data writer object. Data writer object. Is that not what this is? Do you not have access to this? What did I mess up here? Oh, yeah, duh. I don't know what just went through my head there. Okay. Should be async task. And that means we need the data writer object in here too. We're not notifying users because we're not into that sort of thing. And then we need that write async as well. So let's grab that. Got write string there, that's fine. Write async. No notifying users. Got some more namespaces to bring in, and we need that data writer object. So let's go grab that, which is again just to initialize at the top, like the savages we are. Now that's good. I don't even care about that, honestly. We need to create a new lock. Object new. Alright, we're almost there. And we need to grab a new, yeah, where's that token coming from? These all being like initialized somewhere. You know, I'm not even gonna do this with good task management. I don't care. Dot none. Alright. Let's see. What we want to do is data writer object dot write string, and we're gonna say reload, and we're passing in a \n there because we're using, that's the same thing we did in here. The reason for that is because, like on our serial monitor, we're using new line as our denotion of a separate command that's being sent, because serial is always just strings over and over again. Like, it's every time we send an individual byte, we're sending that over. So, the phrase reload is a whole string of bytes. So we need to be able to denote when it's sort of the end and when we're actually accepting it as a new command. And so we denote that with the new line. That's where that's configured there. Okay. Now we should be able to run this. And hopefully we get the same result there where all it does is... Oh, wait. Did I just write the wrong one? No, stop. Hopefully we get the same thing where it just types an R somewhere. But we'll know that it's not coming from the key injector now. It will be coming from our Arduino writing for us, which would be really cool. Okay, connect. For some reason, it doesn't think it's actually connected. Connect there. And, okay, Alexa, open Warzone controller.
Welcome to the Warzone controller. Issue a command like jump or cut shoot.
Reload.
You are reloading.
Let's see. We hit a breakpoint here. Alright, so device is not actually connected. So that makes sense. We're not actually connected at all. Really glad we added this here to actually see what's going on. Now let's see. I'm going to throw some of these in here as well. And let's see why we're not actually connecting. So we copied all of that code over. Connect. Oh, we're in the wrong section. I want to look for connect in here. On device connected. Select device in list. So let's go into that on our end. Device in list. Let's see if we get in here and run it. Alright, something's up with our button not actually doing anything, I don't think. So let's see. Button, connect to device. Connect to device, click. Let's step through this. Alright, so we've got this selected. We connect. Do we have a selection? We do. We have an entry. We have all the selector information. New event handler. On device connected. On device closed. Open device async. False. Okay. So this is not working. Step into here. Let it run. We'll go back and click it again. Boop. Alright. Device is null. Interesting. Oh, we don't have freaking permission. We need to update the manifest. Alright, so just like we did before on the other one, let's open this with the XML editor. And back on this one, I got to go copy that value. So same thing, opening the package manifest with the XML editor so we get that raw stuff. This bad boy we want in capabilities. Now, eventually we'll be able to get rid of this too, the restricted capability. But for now, let's step through and make sure we can get to our device in the list. Alright, device should not be null. There we go. Alright, let's just let it run through. There we go. We are connected. And we're going to connect to the remote controller. And now, Alexa, open Warzone controller.
Welcome to the Warzone controller. Issue a command like jump or cut shoot.
Reload.
You are reloading.
Okay, we have commands coming from Alexa through our UWP app over Signal R, running through our Arduino over a serial connection, and back out through USB. Now, can we do this in-game? So, a couple things here. We know we can't run while debugging because that crashes the game. So we need to rerun Warzone controller client. Let's get everything connected. And let's make sure we get it in our command log too. Actually, we might have got rid of that, but either way. Yeah, thanks, Raventhorn. I'm so pumped. It's been such a long-running thing now. The final moment of truth is about to come up as to whether this project is dead or not, because I am out of other ideas. Let's see. Alexa, tell Warzone controller to reload.
I'm not quite sure how to help you with that.
I know. Alexa, open Warzone controller.
Welcome to the Warzone
Alexa,
controller.
reload.
You
Alright,
are reloading.
we're running. Let's hop into Warzone. Okay, Call of Duty, please, please accept my inputs from my Arduino. I'm begging you. Alright, don't crash. Please don't crash. The debugger's not running on anything, right? Everything's fine. Come on. I'm getting so rowdy. I hope this works. Okay, we're still going to jump into orientation here just to make sure we're not going to get booted for anything. Alright, Alexa, open Warzone controller.
Welcome to the Warzone controller.
Alexa, reload.
You are reloading.
Let's go! No way! You guys see it? Hands off, right? Alright, I'm gonna shoot. Alexa, open Warzone controller.
Welcome to the Warzone controller. Issue a command like jump or cut shoot.
Reload.
You are reloading.
Finally! Oh my god! Oh my god! Okay, let's go set up all these other commands. Oh my god, yes! Okay, we're gonna quit because we gotta debug some more and we don't want it to crash. Oh my gosh, I am so happy. Okay, so we've got reload working. Let's go take a look at our other commands. We don't need this stupid demo thing anymore. We just want our also ugly code. And we've got, let's see, I'm just going to minimize all this, right? Let's keep all our stuff up here. We'll even move these down here. Thank you, Kenzie. Just getting a text from her upstairs hearing me cheer and yell over stream. Okay, so we've got hit key. Basically, we should take this as a string instead. String command. And instead, we'll pass in command here. And now all of these other places where we're hitting hit key and the button click setup, we just need to pass in the command. So, actually, I wonder if I can make this generic, like if I could just pass in the intent. No, it's fine. Everything's fine. We'll do it this way. Let's do armor, sprint. We'll worry about attacking later, but we could always bind this to a different key. Ping. This one I'm actually going to do a little differently because I want the Arduino to handle the double ping. Actually, no, we do want both. We're going to send 2 pings. Oh, and I guess these all need to be async. And we should await these. I can't believe that worked. We've been working on this project and got so close so many times just to like jump into game and hit the wall of like, oh yeah, you can't actually do anything. Ooh, it just ignores everything. Because like all of this original setup we did in like an hour. It was insane. And then we had to wait for, you know, Arduinos to come in the mail, and we worked on some other projects because, you know, everything takes forever in Corona times. And also there were more important things to worry about, say cut there, than stupid video games like building stuff like this. But here we are making it happen. And now we're just wiring up our commands, awaiting all this stuff. Await, crouch. Oh, whoops. Okay, this one's gonna be different because we actually need to like press and hold for a little while, but we could also always bind it to something else. So actually, we'll still do await, hit key. Oh, someone's at my front door. Oh, hopefully Kenzie can handle that. We'll send along prone. Sorry for my dogs barking in the background. They're almost as excited as me. And this needs to be async. And these should all be lowercase for consistency. Okay, so we need to add, we have reload. We need to add armor and sprint, and eventually we'll talk about attack stuff later. Ping, double ping, we'll just need ping, cut, jump, crouch, okay, all that stuff. I'm actually just gonna keep this pinned here and we'll pull this over. So let's do, how many do we need? We got reload, armor, sprint, ping, cut, jump, crouch, prone. All right. So we've got armor, sprint, ping, cut, jump, crouch, prone. And we'll create some new functions in here. Armor, sprint, ping, cut, shoot, jump, crouch, prone, and set debug. Alright, so now we want to be able to take these, and what I want to do is house these in a send key press, or send basic key command. And then I think one of the other things we're going to need in the future as well, and this is going to unlock like even more stuff when we get into other ways to make this more distributed, but we're going to want to add like pressing and holding for a certain amount of time, because like I've got this whole sort of thought in my head where I want to build like an actual Twitch bot where you all in chat can send commands just by typing in chat and say like walk forward 3 seconds or something like that, and it'll make sure it holds W for 3 seconds, and then someone else can at the same time say shoot, so we can be walking and shooting, and that was actually controlled by 2 people. I think that'd be super cool. So let's say we want a character key, and we'll press key. So in this case, all we need to do for reload is say send basic command of R, and then we're also going to want to do a press, actually yeah, that's fine. Okay, so reload is that, and now we need, get rid of this comment, that's all just nonsense. Right, so we got reload, and we want to do armor, sprint, ping, cut, shoot, jump, crouch, prone. Okay, armor, sprint, ping, cut, shoot, jump, crouch, prone. Did I like forget one? Reload. Oh, armor. I got rid of armor on accident. Armor. Alright, so this is 4. Prone is key, left. Oh, actually, this is going to be something else. We're going to leave this empty because we're going to want to hold that one there. Crouch is, for me, it's control. Default is C, which would be the same as cut shoot, but it's key left control. What was it again? We have it in the browser, I think. Key left control. That's the one. Not fully spelled out. Jump is space, so I think that's key. Actually, we could probably do it. Isn't that? Cut shoot is C. Ping is key left alt. Key left alt. I assume that is the. No, get rid of that. This one. We just did it in the alt tab sample. Don't need that. Don't need that. Don't need that. Nope, nope, nope. Don't need that. We'll keep our other stuff up. We'll get there. We'll get back there eventually. Okay. Okay, yeah. Arduino. Yeah, key press tab. Show me that. Keyboard modifiers. Yeah, left alt. Hopefully that works. Alright, back over here. Key left alt. Sprint is shift. This is gonna be another one where like sprint we need to like hold. Key left shift. And reload is R. Alright, can we build? Cut shoot was not declared in the scope. Oh, cut shoot load. Build. Jump was not. Oh, whoops. Did I do that all over the place? Reload, sprint, ping, cut, shoot, jump, crouch, prone. Here, you know what we're going to do? For prone, we just want to delay like half a second. We're going to press left control, delay, then. And that's fine. We could always just add an optional delay here if we wanted to. Which we might do that in a little bit. All right. Okay. Build. Unexpected token. I'm a ding dong. What did I forget? Oh. Oh, we're missing these all over the place. Now build? We're doing it. Alright, uploading. Oh, we're still connected. Disconnect. Upload. Now we can kill this. Run this again. And we'll cycle through it before we jump in game. Alright. Connect to that device. Don't need that anymore. Connect to remote. Alright, now let's like open up a tab and start typing. Alexa, tell Warzone controller to put on armor.
You are putting on armor.
Alexa, tell Warzone controller to reload.
You are reloading.
Alexa, tell Warzone controller to jump.
You are jumping.
Well, there it is. Alright, I gotta throw this up on Twitter. More people need to see this. Can't even remember my own damn handle. Yo, please retweet this. I want people to see this glory. We're going to be yelling at the Alexa in Warzone, finally. Okay. We need to stop debugging because we know that crashes the game for some reason. Respin up the client without the debugger. Connect to that. Connect to the internets. Alexa, tell Warzone controller to reload. There we go. All right, let's get in game here. Let's go test it out. We'll go through the tutorial, and see what we can do, and then we'll drop and start yelling at Alexa to do all this stuff. I should probably bring this on in frame too, so you can see this thing. Clean up all my Arduinos. And sorry for the deafening intro from Infinity Ward. Okay. We can do this in multiplayer too, if we wanted to. I think that'd be pretty funny to do like shorter games. I'm gonna do the orientation just so we can try all of the commands out, make sure everything's working, and then we'll jump in game into an actual solo game. Oh, we need to do pick up item. That's fine, that's fine. We gotta do that stuff way too fast anyway. Alexa, tell Warzone controller to put on armor.
You are putting on armor.
That's so funny. Alexa, tell Warzone controller to put on armor. Alexa, tell Warzone controller to put on armor.
You are putting on armor.
Alright, let me just move on. What? What does it want me to do here? Take cover behind a concrete barrier. There, you like that? Switch weapons. Oh, that's another one we can do. We just switch weapons. There's so many more commands here that I'm learning we need to do. Mount. Uh-oh. Okay, let me through. Let me through. Let me out of here. Oh, it's another one. Open map. I gotta like write these down. Someone take a note of all these. We need mount. We need map. We need swap weapons, and probably a few others. See if we can't do Alexa, tell Warzone controller to crouch.
You are crouching.
All right, ready? I'm gonna try to do a sprint slide here. Alexa, tell Warzone controller to sprint. Alexa, tell Warzone controller to crouch.
Sorry. I don't
Alexa,
know.
tell Warzone controller to crouch. Alexa, tell Warzone controller to crouch.
You are crouching.
Aww. Oh, it needs to like release faster. What does it want me to do? Alright, let's just go jump in a game. We gotta do cut, shoot, and jump too, so we gotta make sure that works. I'm gonna do the full like parachuting game we're gonna do with just Alexa. So cutting, shoot, and parachuting, and hopefully we don't die right away. Just waiting to queue up. You know, this might also work on Google. Hey Google, ooh, unmute. We'll wait till we get in game, but we'll try both. Because I think we had it, did we have it working on Google? No, I don't think we finished setting up the Google Action because we were running into issues with the Dialogflow package being a pain in the butt. Alright, we're going to drop. We're going to choose a spot to drop, and we're going to use Alexa to yell it to cut, shoot, and jump, because jump will be the same thing as opening parachute. All thanks to this little beautiful piece of hardware and like 50 lines of code. Alexa, tell Warzone controller to jump.
I don't know that.
Alexa, tell Warzone controller to cut, shoot.
You are cutting your shoot.
Alexa, tell Warzone controller to jump.
You are jumping.
Jumping to my death. Lovely. Alright, I'll turn the volume down on this so it doesn't come through the mic. Alexa, tell Warzone controller to jump.
You are jumping.
Alexa, tell Warzone controller to cut, shoot.
You are cutting your shoot.
Okay, let's see. Alexa, tell Warzone controller to jump. Oh, it's too late. We gotta figure the timing out. Alexa, tell Warzone controller to jump.
You are jumping.
Alexa, tell Warzone controller to cut. Ignored. I'm gonna need like a hot button over here to yell at her. I'm like yelling too frantically. I don't think she's gonna pick it up as well. I cannot wait to turn this into a Twitch bot and have everyone in chat telling me what to do and just controlling my guy. We gotta just add more commands and more stuff to do. Alright, we've got a great circle here. It's the whole damn map. So let's go try to find a contract that is reasonable to get to. Alright, hands off. Alexa, tell Warzone controller to jump.
You are jumping.
And we're off. Alexa, tell Warzone controller to jump. Oh, that was clutch. Okay, we landed a little further away than I wanted. There's definitely some people landing over here too. Yep, this guy's probably going to get that contract first, which means that we're going to want to grab some guns and see what we can't do in a fight here. Oh yeah, we got to use grenade and use alternate grenade. There's so many more things we got to do here. So many more commands. Alright, we're just going to keep throwing these around, so if this guy comes up, he's going to eat those. Alright. Let's see. Alexa, tell Warzone controller to put on armor.
You are putting on armor.
Yes, we are. Is there someone in that window? It's like glare. No, there is someone in there. Alexa, tell Warzone controller to crouch.
Sorry, I'm not sure.
Ah, so close to glory. Alright, well we got one kill. Good start. No contract. We can go grab this bounty. Alexa, tell Warzone controller to crouch.
You are crouching.
Oh, power slide powered by Alexa. Alexa, tell Warzone controller to jump.
You are jumping.
It's so weird. Like having it just do something for me while I'm just like a little bit delayed and like still playing is so funny. We got to definitely have like a use item thing as one of them as well. Okay, let's see if we can't find some better weapons. We'll go hunt this guy down, and then keep it moving. I definitely like that better. All right, I haven't played solos in a while either. Oh, we'll be able to do like drifting powered by Alexa. All right, check this out. Ready? Alexa, tell Warzone controller to jump.
You are jumping.
Boom. Big drift powered by Alexa. All right, let's go see if we can't hunt this guy down. It's on the other side. I'm gonna grab some armor and stuff. He's probably just camping in here. So we'll do this. Freak him out with smoke. Oh no, he ran. He's on the run. Alright, where is he? Alexa, tell Warzone controller to crouch. Alexa, tell Warzone controller to crouch.
You are crouching.
It's so cool. Got him. Oh, that was not our bounty. Alright, so we still got someone right above us. Nothing. And there's someone right outside shooting too. Let's see if we can't get this. He's gonna be in this apartment. Or he's right above me. Oh, I'm bad. Oh, I'm bad. I'm so bad. I have so many fewer frames than normal. I like having to, first time running OBS and Call of Duty at the same time. I gotta like re-optimize my stuff. Oh, we gotta do spray paints too. Like, I should be able to do that, or like gesture, or look at my watch or something. Oh, that's where that one didn't show up. Oh, there's like so many more commands we gotta add. It's gonna be awesome. Alright, let's see if I can win a game here. Nope. Okay, not bad. 97th place. At least we used Alexa to get down, and we used her for some cool power slides and reloading and putting on armor and stuff. So, you know, I think there's some more commands we can add. We gotta do like opening the map. We gotta do picking up items, or like opening doors and stuff. We need to do swapping weapons. We need to do using grenades. We still need to do like shooting and stuff like that too. So that's awesome. Okay, I think I'm gonna probably call it here because there's quite a bit of stuff that we can do, and I think I'm gonna save it for Sunday. So we were able to get this set up. We got the Arduino. We learned how to do a whole bunch of basic Arduino stuff with serial input and output and using the keyboard functionality that the Leonardo supports. And we actually got everything hooked up and working, and sending commands from our UWP app that's listening over Signal R to our Alexa skill that's just an endpoint over in Azure. And we're actually executing commands that are working in game. So I think there's a couple next steps. I want to do I want to add these new commands. There's a whole bunch of stuff, and I'm going to just think about all the other ones we want. I want to be able to add like time-based commands. So if I say like sprint for 3 seconds or something like that, or like shoot for 2 seconds, or move forward, like left, like we got to do all the movement stuff. Other than maybe like the mouse positioning, that might be a little weird. And that way, like we can literally play Call of Duty one-handed and use our voice as the other one. Now, that's fun and all. What I think will be funnier is letting everyone else also do it. So Sunday, let's get all these commands added. Let's get this deployed on Alexa and Google to the stores. That way, everyone else can get... Actually, why don't we just deploy the Alexa skill now? Let's just do that real quick. We already have it like ready to go. Let me disconnect everything. Right, we already have it. Like, let's just go actually deploy this thing. We got Warzone controller. We've got distribution. We already passed all the certification stuff. We already entered all this stuff in. Save. Don't need to run. Submit it. Alright, so hopefully we'll hear back in a couple days. So Sunday, this might actually already be out there. So Sunday, new commands, time-based stuff, so we'll use new slots. That'll update our language model and everything too. We'll get Google set up and deployed. And I think we should build a Twitch bot and a Discord bot. And I'll get you all invited to the Discord for Suave streams, and we can do it in Twitch. So that you guys can just send commands in the console, and it will actually affect the character, and then we can actually go play the game. Now, all of that is super fun. I think that it would also be really cool to do it with some other games, with some other bindings. So, like, we tried Dark Souls before, but I feel like that would be a really cool game to do with, like, everybody playing, and hopefully we can build quite a crowd around that, or even get some of the other streamers out there that play Dark Souls, or even some of the ones that play Warzone, to try this out. We can just ship them a Leonardo and instructions on how to run everything, and have everyone play, and then other than maybe me like moving the mouse, and that's all we have to worry about. I feel like that'd be so funny. And then we'll do Dark Souls, and then the long run. This is all sort of like a proof of concept for a much larger project that I want to work on for an accessible keyboard. Like right now we're sending basic commands and stuff, but what my goal is to create an app called Suave Keyboard, and be able to say like tell Suave Keyboard to type, and then just like say a sentence and have it actually type. I think that, or individual characters or whatever. I think that would be extremely useful. It would be great for people with like issues using keyboards. Even people that aren't handicapped in any way, and can still use it from a distance. Like I could be away from my computer but still actually like type something on it just by using my voice. That would be really cool as well. So all of this will build up to that, but we'll do some of this fun video game stuff in between, and then we'll also check on the Find My Rep. So Sunday, Google deployment. We're going to build a Twitch bot. We're going to use C# again. I've never built a Twitch bot before, so we're going to figure that out. If it's easy, we'll build a whole bunch of them for other things too. We'll build the Twitch bot for this. We'll build more commands into it. We'll build timing stuff, and then I think we can just get more people involved in using it and in chat, and it would be really funny. But thank you all for joining. This was a huge moment for this project. This was like the breakthrough moment we needed, all thanks to this beautiful like $15 piece of hardware and just a little bit more time. I feel like I got my head wrapped around everything that we needed to do and how it's all working, which is great. And then, we can always do some refactoring. I'll probably just clean up the code on the side anyway. But I'll push all this stuff to GitHub. It'll all be up there by the end of tonight. And then I'll see you all Sunday at 12:30 p.m. Eastern, and we'll just keep this thing moving. So thank you all for joining and taking part in the chat and being here for this sort of fun moment in the project. I'm so excited. And I'll see you all on the next one on Sunday. So take care and good night.